going to look at Pythagorean's theorem, which is an important theorem for right triangles. It helps us to find the length of one side of a right triangle. A right triangle has one 90-degree angle, which is indicated with a small box in the right angle. The side opposite the right angle is called the hypotenuse. The other two sides are called legs. We will label the sides of the right triangle A, B, and C. The hypotenuse is always C, and the legs will be A and B, and it doesn't matter which one is which. And Pythagorean's theorem states that if we square the length of the legs and add them together, that will be equal to the square of the hypotenuse. So a squared plus b squared will equal c squared. Let's use Pythagorean's theorem to find the length of the hypotenuse of this triangle. We'll label our triangle. Remember, the hypotenuse is always C, and the legs are A and B. And then we'll substitute into our theorem. The 6 is A, and we'll square it, plus the 8 is B, and we'll square it, equals the hypotenuse we don't know is C. Then we'll do the math on the left-hand side. 6 squared is 36, plus 8 squared is 64, equals C squared. Add together, 36 plus 64 gives us 100, equals C squared. Now, we don't want to know C squared, we want to know C. So this is where we take the square root to get just C. So do the square root of both sides, square root of 100, and square root of C squared. Square root of 100, this is a perfect square, gives us 10, and the square root of C squared gives us just C. So our hypotenuse is 10 feet. Let's look at this example. We have a right triangle, and one leg is 5 inches, and the hypotenuse is 7 inches. They would like for us to find the length of the other side. So let's label our triangle. They're giving us one of the legs. So we'll call this A, and we'll say it's 5. They're not giving us the other leg, so this will be B, and this is the one that we don't know. Our hypotenuse is always C, and it is 7. So we'll write our theorem, A squared plus B squared equals C squared, and we'll plug in what we know. We have A, so we plug in 5 and square it. We don't know B, so we'll keep the variable. And we do know the C is 7, and we'll square it. Now we'll do all the math that we can. 5 squared gives us 25. And 7 squared gives us 49. Now, we would like to isolate the b squared, so we use our equation solving skills and get the b squared by itself. That means we need to get rid of the 25. It's a positive 25, so we'll subtract it on both sides to make it cancel. So we'll subtract on the left, and we still have our b squared. And then we'll subtract the 25 on the right-hand side. Clean up. We're left with b squared equals 24. Now, we don't want b squared, we want b. So this is where we take the square root. We'll take the square root of both sides. On the left-hand side, the square root of b squared will leave just b. And 24 is not a perfect square, so our exact answer is to leave it with the radical form. We can make an estimate. If you recall, 5 times 5 is 25. That gives us a perfect square. And that's a little bit higher than what we have. So if we go lower, 4 times 4 is 16. That's the next lowest perfect square. We're somewhere in between. We're much closer to 25. So on this side, we're between 4 and 5. I'm going to guess closer to the 5. So I'm going to guess B is about 4.9. So I'll use the wavy lines for approximately.